These notes are on section 4.1, Congruent Figures. In order to have two congruent triangles, these are the things that you need to have. You need to have three corresponding angles that are congruent. We also need to have three corresponding sides that are congruent. And if all six corresponding parts are congruent, then the triangles are congruent. The word corresponding refers to the pieces of the triangle that match up. If I were to take this triangle, DMG, and lift it up and drop it on top of this triangle, LCK, the pieces that match up would be considered the corresponding parts. For example, D would correspond with L. M would correspond with C. And then segment DG, since it has one congruent line, would correspond to segment LK. If two triangles are congruent, you can write what's called a congruency statement. A congruency statement would look something like this. Triangle DMG is congruent to triangle. And then when you rewrite the second triangle, you need to make sure that your corresponding parts match up. For example, when I named the first triangle, I chose to name D first, and D corresponds with L. Which means when I name this triangle, I need to name L first. M, angle M, corresponds to C. And we would write that second. Angle G corresponds with K. So we would write that third. So triangle DMG is congruent to triangle LCK. This right here is a congruency statement. These top two triangles right here are just some more practice if your figures were switched around a little bit. If I look at this picture and I write a congruency statement, I could say triangle AXF is congruent. I could say is congruent to triangle BMN. Again, in that same order, because those are the congruent sides. This one down here, it kind of works backwards. I give you a congruency statement, and the pictures don't have any marks in it, but you can still tell their corresponding parts in the way in which the letters are ordered. For example, B is listed first in this triangle, and E is listed first in this triangle, which means angle B and angle E have to be congruent. So we can put congruent marks here at B and E. C is written second and F is written second, which means that angle C and angle F have to be congruent. So we can put our marks there. And lastly, angle D and angle A have to be congruent. So we can mark those. Notice the congruency measures. So with these congruent measurements, we can see that one little arc means that these are congruent, and two little arcs means that these are congruent, and then three little arcs means that these are congruent. These are identifying the corresponding pieces. So angle F, and angle F here, would be congruent to angle C. And segment DE would be congruent to what? So we look here, segment D would be congruent to segment AB. So if I look at up here in this congruency statement, segment DE is the third letter and first letter. So if I go over into this first triangle, the way it is written, angle A and B are written the third letter and the first letter. So DE has to be congruent to AB. And you could also go over here and mark your picture as well. So we could put a mark here and here. Same thing here with these triangles. This is a congruency statement. You could go mark your triangles, and then here it's just identifying the corresponding parts. When you see something like a segment ED is congruent to a blank space, it's not looking for a number here. If it wanted to know a measurement, it would use an equal sign and not a congruent sign. The theorem on this page states that if two angles are congruent, which means angle D and C are marked congruent, angle G and angle L are marked congruent. If two are marked congruent, then the third set is also congruent, even though it may not be marked. So because I have two angles that are already marked congruent, I know that angle K has to be congruent to angle M, and angle M has to be congruent to angle K, because if two angles are congruent, the third set also has to be congruent, because all six corresponding pieces are congruent. Triangle DGM has to be congruent to triangle. Again, when you look up here, you have to make sure your corresponding parts match up. So if I said D first, which letter corresponds to D? C. So I have to say C first. I said G second. Which letter corresponds to G? L. And finally, M corresponds to K. And again up here, angle M would correspond to angle K. In this example right here, we are given a congruency statement. And we are asked to solve for X and Y. It's saying triangle ABC is congruent to triangle JKL. Segment AB, which is right here, the first two letters of the congruency statement, has to be equal to segment JK, which again is also the first two letters of the other triangle in the congruency statement. So AB has to be congruent to JK. So I can set 3x minus 3 equal to x plus 6. And if I add 3 to both sides and subtract x, I end up with 2x equals 9. So x equals 4.5. I can do the same thing with angle measurements. Angle C is being noted as 9y plus 4. And angle L is being noted as 20y minus 18. C is the third letter in the congruency statement, and L is the third letter, which means those angles have to be congruent. So I can take 9y plus 4 and set that equal to 20y minus 18. Subtract 9y from both sides. Which gives us 4 equals 11y minus, minus 18. Add 18 to both sides, and we end up with 11y equals 22. Divide off your 11, and y equals 2. Now you're going to have the next few minutes to complete these last couple pages on your own. In this first one, you're given the congruency statement, and you need to draw and label a picture and complete these statements over to the side. And then on this last page, you need to state the congruency statement and solve for x, given these two figures.